Welcome to the session for Gd&T for Design and Quality Engineers. In this session, we are going to see the Gd&T rules and concepts. Maximum Material Condition (MMC). MMC is that condition of a part or feature which contains the maximum amount of a material. For example, minimum size hole or a maximum size shaft. This is a symbol of MMC. Maximum material condition is the condition in which a feature of size contains the maximum amount of material everywhere within the stated limits of size. Maximum material requirement is another brilliant modifier that you can use to save the manufacturing costs while still satisfying the function. As the name suggests, maximum material requirement means the geometric tolerance is only valid when the size dimension is at its limit. That results in the part having maximum possible mass material. In other words, the tolerance limit that results in the heaviest part. So, for shaft with an outer diameter of 10 plus 0.1, the maximum material condition is 10 plus 0.1, which equals to 10 plus 1. This is the size that results in the shaft being at its heaviest condition. But for a part with a hole that has a diameter of 10 plus 0.1, the maximum material condition is when we have the smallest hole, that is when the part is at its heaviest condition. So 10 minus 0.1, which equals to 9.9. Next is LMC, that is least material condition. Least material condition is the condition in which a feature of size contains the least amount of material everywhere within the stated limits of size. Least material condition is just like the opposite of maximum material condition, that is MMC. Now let's look at how we can use these conditions to save money. By adding a letter M in a circle after the geometric tolerance. For example, the position tolerance, we are saying that the value of the tolerance is only valid the part is at its MMC, that is maximum material condition. If the part did not reach its limit, then the manufacturer can add the unused tolerance to the value of geometric tolerance. If I have this part with these two holes, both have a diameter of 5 plus 0.1 and the distance between the two holes is 10, and I add a position tolerance on the diameter of this hole of 0.1 to datum A, while A is the diameter of the other hole. This would mean that the value of the position tolerance zone is 0.1. But if I add the M in the circle modifier to the feature control frame next to the tolerance value, this means that the 0.1 is the only valid when the whole size is at its MMC of 5 minus 0.1, which is 4.9. But if the hole was actually 5, then I can use this extra 0.1, add it to the value of position tolerance. So I am actually allowed a position tolerance of 0.2. And if the hole was 5.1, then I can use the 0.2 difference between the real measurement and the MMC and add it to the position tolerance. So now I got 0.1 plus 0.2, which equals 0.3. By doing so, we can allow the manufacturer to have more deviation in one tolerance if the other tolerance is precise. The MMC can also be applied to the size of the datum feature by adding the M symbol to the feature control frame. This way, the dimension has to be at its maximum material condition in order for the geometric tolerance to be value is the size of the datum feature. Further, we will see the rule, that is rule number 1, which include individual feature of size perfect form at MMC, where only a tolerance of size is specified. The limits of size of an individual feature prescribe the extent to which variation in its geometric form as well as sizes are allowed. Next is rule number 2. Rule number 2 states that RF sepals with respect to the individual tolerance, datum reference, or both where no modifying symbol is specified. MMC, that is maximum material condition, and LMC, least material condition, must be specified on the drawing where it is required.